Today, we're diving into a really persistent challenge in the world of human-AI interaction. And that is, how do we get large language models to move beyond being just passive tools and become truly active, collaborative partners? A new paper introduces a framework designed to do just that, teaching models to think about the long-term success of a conversation. Let's dig in.
So here's how we'll break it down. We're going to follow the paper's arc, starting with what they call the passive responder problem. Then we'll get into their solution, COLLABLLM, and the really clever Multiturn-aware Reward system at its core. After that, we'll look at the data, both from experiments and from real-world user studies, before we zoom out and talk about what this all means for the future.
All right, so the core issue the paper tackles is this passive responder problem. We've all been there, right? You give a model a slightly ambiguous prompt, and instead of asking for clarity, it just plows ahead, generating this long, confident response that's completely off the mark. And that kicks off this frustrating back and forth of you trying to correct it.
Exactly. And the paper makes a great point that this isn't the model's fault, really. It's a product of how it was trained. Most models are rewarded for maximizing the quality of the very next turn. The incentive is to give a plausible-sounding answer right now, even if taking a step back to ask a question would lead to a much better outcome for the entire task. It's a fundamental misalignment with how people actually collaborate on complex problems.
And this slide just lays out those two paths so clearly. On the left, you've got that classic cycle of frustration. Vague prompt, wrong answer, correction, rinse, repeat. But on the right, you see the collaborative approach. The model proactively asks for details. What's the tone? What's the scope? And that simple act of clarification gets you to a great result so much faster.
So, to bridge that gap between the frustrating path and the collaborative one, the paper proposes a new training framework they call COLLABLLM.
Right. The whole game here is to change what the model is optimizing for. It's not about winning the current turn anymore. COLLABLLM is trained to think ahead, to ask itself, how will my response now affect the entire conversation down the line? It's learning to be strategic, to anticipate what the user needs, and steer the interaction toward a successful finish.
Okay, but that's the million-dollar question, isn't it? How do you actually get a model to be forward-looking? Well, the technical heart of this whole thing is a really neat mechanism called the Multiturn-aware Reward.
Exactly. So instead of just getting a score for one good answer, the model is rewarded based on the estimated value of the entire conversation that it thinks will happen after that answer. And it does this through simulation. It plays out a bunch of what-if scenarios. If I ask this clarifying question now, what's the probability we get to a correct solution in 3 turns? It's a big shift from just learning a preference to actually estimating a causal effect.
This diagram here really shows how that process works. So the user gives a prompt, and the model comes up with a possible response. But, and this is the key part, before it gets a reward, the framework kicks off a simulation. It uses a separate user simulator to play out how the conversation might unfold. That simulation allows it to calculate the multi-turn-aware reward for that first response. Then, it uses reinforcement learning to fine-tune the model, telling it to prefer the actions that led to better long-term outcomes in those simulations.
And that reward it's aiming for isn't just one thing. It's a combination of 2 components. You have the extrinsic reward, which is all about task success. Did the code actually run? Was the math problem solved correctly? But then you have the intrinsic reward, which is all about the user's experience. Was the conversation efficient, or did it waste a bunch of tokens? Was it interactive and engaging? It's a really holistic way of defining what a good collaboration actually looks like.
Okay, so the theory is really elegant. But the big question is, does it actually work? To figure that out, the paper puts COLLABLLM through its paces in a series of simulated experiments.
And the results are pretty darn compelling. This table compares COLLABLLM to a pretty strong baseline, basically a good model that's been specifically prompted to ask clarifying questions. And you can see across document editing, coding, and math problems, COLLABLLM comes out ahead. That 32% jump in accuracy on math problems is especially impressive. It suggests the model isn't just guessing better, it's actually learning to collaborate to find the right solution.
And what I think is so striking are these average improvements here. Yeah, task performance is up almost 20%, which is great, but look at interactivity. As judged by another LLM, it's up by over 46%. This is a huge signal that the model isn't just becoming a better problem solver, it's becoming a fundamentally better conversationalist.
This case study from the paper just makes the difference so concrete. A user asks for a tokenization function. The base model just barrels ahead, makes a bunch of assumptions about how to handle the text, and, unsurprisingly, gets it wrong. COLLABLLM, on the other hand, just stops and asks, hey, which tokenizer you want to use? How should I handle errors? And that one simple step leads straight to the correct answer.
And this slide gets right back to the why. It all comes down to that multi-turn-aware reward. A simple reward model might actually prefer the base model's long, confident-looking answer, but the MR simulation correctly predicts that asking a question now, even if it feels like a step back, will ultimately lead to a much better final result. It assigns a higher score to the more strategic, more collaborative action.
The researchers also did a really cool generalization test. They took the COLLABLLM that was trained on coding tasks and threw it a general question answering task. And you can see the base model just answers, no matter what. But COLLABLLM shows this learned behavior. When the query is ambiguous, it chooses to ask a question more than half the time. It has learned the general skill of identifying and resolving ambiguity, and it can apply that skill in a totally new domain.
Okay, simulations and metrics are one thing, but the ultimate test is always how these things perform with real human beings. So the researchers went ahead and ran a large-scale user study with over 200 people to see how COLLABLLM held up.
And the results were really positive. When they asked users to rate the quality of the final document they created with the AI, you see that over 91% of them rated COLLABLLM's output as either good or very good. That's a pretty powerful signal that the entire collaborative process is working as intended.
Yeah, and the quantitative data really backs that up. User satisfaction was up almost 18%. But just as importantly, people were more efficient. They spent over 10% less time on their task. And this last point to me is the most telling. With the base model, user ratings actually went down the longer the conversation went on. But with COLLABLLM, they went up. It seems like real collaboration actually builds trust and value over time. And this quote from one of the participants just captures that qualitative difference perfectly. People felt the AI wasn't just spitting out answers. It was a partner in their thinking process. It was helping them consider things they hadn't thought of. And that, right there, is the shift from a passive tool to a true collaborator. So, let's bring it all together and talk about the big picture. What are the broader implications of this kind of research? And what are some of the limitations we need to keep in mind?
Well, this table does a nice job of summarizing what makes the COLLABLLM approach novel. It's designed to be task-agnostic, it's very user-centric, and that causal reward mechanism is a real differentiator. But we have to be clear about the limitations. This entire framework hinges on having a good user simulator. If your simulator doesn't behave like a real user, you could optimize your model for the wrong kind of collaboration entirely. And on top of that, the computational cost of running all those forward-looking simulations is not trivial. That's a real hurdle for scaling this up.
And that brings us to the final critical question. This research, even with its current limitations, points toward a future where we don't just use an AI, we genuinely partner with it. If we can get to a place where our AI can anticipate what we need, help us clarify our own thinking, and steer us toward better outcomes, it stops being just a tool. It becomes an extension of our own creative and problem-solving abilities. And that could fundamentally change the nature of how we work.